All right, in this lesson, we're going to do something called polynomial long division. Now, to start this, I'm actually going to go and do a quick problem to remind you how to do numeric long division. So you can see how it applies to numbers like you used to do, I don't know how many years ago, and then how we can apply it to polynomials. So I'm going to scroll past the problems that we're going to do and put this at the very, very end as just a quick example. All right, so example. Let's say I want to take 1,723 and divide it by 5. Okay, so I'm going to set this up as a division problem. Well, it is a division problem, but I'm going to put it into the actual division box. So my divisor is what I'm dividing by, that's 5. And then my dividend is what I'm dividing into, and that's the 1,723. So what I'm going to do is I'm going to start by seeing if this 5 can divide into the first number. So can I take 5 and divide it into 1? Not evenly, no. So I'm going to move on and see if I can take 5 and divide it into this pair of numbers. So this turns into a 17 now. So 5 goes into 17 3 whole times. And now I'm going to take this 3 times this 5. So that turns into 15, stack it up, and subtract it. So 17 minus 5 is 2. And the other numbers in the problem, I'm going to bring down. Okay? So now I want to see, can 5... actually, I'm going to take one of those numbers away. I'm just going to go with the first number down. So now I want to see, can 5 go into 22? So 5 can go into 22 4 times. So let's see, 4 times 5 is 20. Subtract, so that is 2, and then I'm going to drop that 3 down. And then 5 goes into 23, again 4 times. And that would be 20 here, minus 3. Now, there's multiple ways to deal with this end number. You could put a decimal point and a 0 and keep going. I don't want you to do that because that's not going to apply when we deal with the polynomials. Sometimes you will see this written as, so the answer would be 344 remainder 3 with the big R that represents remainder. The way I actually want you to get used to seeing this is this would be 344 with a fraction left over of 3/5. So 3 is the remainder. That's why I have 3 here. And then why did I come up with the 5? Well, because I was dividing by 5. So one of these two options is what we're going to be using for the polynomials. But the whole concept is you're going to be doing division, multiplication, subtraction. Division, multiplication, subtraction. That's the process we're going to go through. So I'm going to go ahead and scroll up to the first problem. And my plan is to possibly break this up into a couple of videos so you can see, maybe not as long if you don't need to. I believe the directions said to write the remainders as fractions. So that's going to be the second thing that we did. So, wow. All right, we've got a 4th degree polynomial. We've got power of 4, 3, 2, 1, and our constant. So we are not missing any terms here. Every variable is, every power is represented, and we are dividing by n minus 3. So I'm going to set this up as a division problem here. And I write large, so I'm going to try and give myself room here. So 3n to the 4th minus 19n cubed plus 23n squared plus 31n. I knew I was going to run out of room there, minus 25. All right, so this is where we're going to start our process. We're going to take the leading term, this leading n value, and divide it into our leading term. Now, you could, if you're unsure or you just need a little reminder, just put this off to the side. So we've got 3n to the 4th divided by n. Well, the 3 is not going to change, and n to the 4th divided by n to the 1st would be 3n to the 3rd. Now, how you stack them up on the top won't matter, so don't worry, just put them up there, figure it out as we go. So that's the division step. Now I'm going to take this number that I just figured out, this 3n cubed, and I'm going to multiply it with both of these terms. So again, you could off to the side write down 3n cubed times n minus 3 if that will help you keep track of your terms. So this is going to be 3n to the 4th and then minus 9n cubed. So those stack up and line up. And we're going to subtract. Now, it looks a little goofy to put the subtraction sign in parentheses, and actually what you could do is reverse it, and the parentheses actually apply to both of these terms. So just be aware of that when you're going to do this problem. Now, one thing with these problems, to make sure that you're doing it right, this term and this term have to cancel each other out. So 3n to the 4th minus 3n to the 4th, 100%, they're going to cancel. Now, remember what I said, it's subtraction here. So negative 19 minus negative 9, that's really negative 19 plus 9. So it's going to turn into 10, or negative 10 n cubed. I'm going to go ahead and bring down the other terms here. Okay. And I'm going to start over. So now I'm going to take this first term, and I'm just underlining it in green, so that n, and I want to divide it into this first term. So let's see. Again, you could put this off to the side. So negative 10n cubed over n. Well, that's going to turn into negative 10n squared. Right? You're just reducing the power by 1 because you're dividing by a single n. So now I need to take negative 10n squared and multiply it times n minus 3. So let's see what happens there. We get negative 10n cubed plus 30n squared. So I'm going to take that and subtract those. All right, so what's going to happen here? Well, my first two terms are absolutely going to cancel each other out. They have to do that or else something did not go right with your division. Now I want to take positive 23 minus 30. So 23 minus 30 is negative 7n squared. Bring down the other values and start again. And we're going to keep doing this until we run out of polynomials. All right, so now I'm going to take this n value. I'm going to put a little pink dot next to it. And I want to divide into this leading term. So negative 7n squared. Let's see, let's go with this one. So negative 7n squared divided by n would be negative 7n. I'm going to multiply. So negative 7n times n minus 3 would be negative 7n squared, and then plus 21n. Subtract those terms. So let's see, first two terms cancel as they should. And then let's see, 31n minus 21n would be 10n minus 25 there. And one more time, all right? So take the little n term and put a little blue line over it and divide it into 10n. This one I'm not going to go ahead and put off to the side. I'm running out of space here, but also just get used to, if you can, 10n divided by n, you're removing one of the n's. There would be a plus 10 there. All right, so let's see. I'm going to take 10 times both of these terms. So 10 times n is 10n, and 10 times negative 3 is negative 30. I'm going to subtract both of those. So last piece here, we've got those two terms cancel each other out. All right, that was good. And then I've got negative 25 minus negative 30, which is really plus 30. So there is a 5 left over there. Now, here's where you stop. There's no more variable here to divide into, so you're done with your division. The last thing to do is, this is your remainder, and it's set in the directions to write the remainder as a fraction. So I'm going to take that 5. It's positive, so we're going to do plus 5 over, and what were you dividing by? Well, we were dividing by n minus 3. So n minus 3. So this whole big old mess at the top is our answer for a polynomial long division. All right, I'm going to go ahead and slide over to number 2, okay, and see if there's any change or any difference, because other than that, this is how you're going to do these all the time, okay? All right, we've got another 4-term or 4th degree polynomial. So 4, 3, 2, 1 constant. All right, we've got all of our terms. And this time we're dividing by 5v plus 10. Okay, so I'm going to take a moment and I'm going to set up the division box. So 5v plus 10. So 5v to the 4th minus 10v cubed minus 55v squared minus 55v minus 51. Okay, so we're going to start at the beginning, and I am going to take this leading term here of 5v and divide it into that first term of my dividend, which is inside the box. So 5v to the 4th divided by 5v is going to be v cubed. If you put a 1 there, totally fine. So now I'm going to take v cubed and multiply it times both of these terms to stack them up. So v cubed times 5v would be 5v to the 4th. V cubed times 10 is going to be plus 10v cubed. All right, first 2 terms cancel each other out. Oop, one thing I forgot, there's a little subtraction bar there. All right, so those first 2 terms have to cancel when you're doing this. I'm going to keep saying it over and over, just so you hear it a whole bunch of times and remember. Now I want to do negative 10 minus 10. No, those don't cancel. They actually create negative 20v cubed. Bring down your other terms. All right, so now start it again. We're going to start with taking 5v and dividing it into your first term here. So let's see, negative 20v cubed divided by 5v would be negative 4v squared. And now I'm going to take this and multiply it, distribute it to both of these terms to figure out what's stacking up here. So let's see, negative 20v cubed and then negative 40v squared. So stack those up and subtract them. If you're not a huge fan of leaving the subtraction sign this way, you absolutely can distribute that in. So if you multiplied with a negative 1, that would become negative, that would become negative, and you'd become a positive out there. So you can do that too. So let's see, these first 2 terms cancel. As I've said repeatedly, they have to. Let's see, negative 55v squared plus 40v squared would be negative 15v squared. You can absolutely grab a calculator to double check some of these answers. Okay, and we start again. All right, so take negative 15v squared here. We're going to divide by 5v. So what is that, negative 3v? Yep, okay. So negative 3v times both of these terms, negative 15v squared, and then let's see, negative 30v. Lots of negatives in this problem, so be careful with those. Again, you could take this negative and distribute it in. So a negative times a negative is a positive, and then also that one become positive. So remember, you'd be multiplying by a negative 1 out front. So leading terms cancel, as they should. And let's see, we've got negative, I think that's 25v there. Let's see, yep, minus 51. So one more time here, we're going to take this leading term here, negative 25v divided by 5v. So that would be negative 5v, and multiply. So negative 25v, and hold on, I made a mistake. There shouldn't be a v at the end of that. That should just be 5, or negative 5. Yeah, negative 25v divided by 5v. The v's would cancel out. My apologies on not catching that earlier. So negative 5 times 5v is negative 25v, and negative 5 times 10 is going to be negative 50. All right, we're going to subtract those. Feel free to go through and add the, or distribute out the negative sign. Totally fine if that helps you. Negative 51 minus negative 50 would be negative 51 plus 50, so negative 1. That's my remainder. Since it's negative, I'm going to put minus 1 over, and then this is what I was dividing by, so that becomes the denominator of the fraction. All right, lots and lots of steps there, but that's also partially because this is just a really long polynomial. Obviously, if the polynomial had shorter terms, you'd have less steps. All right, I'm going to look for one more problem, and it's a specific one that I want to talk about. Let's see. I'm going to go with problem number 5 here. All right, and there's a method to the madness. The other problems I'll go ahead and have on in answer key. Whoops, sorry about that. So those other problems will be there. Obviously, you can ask any questions that you want to. Now, the reason I want to talk about problem number 5 is there's a slight thing that you're going to have to add to this. So we've got v to the 4th, we've got v cubed, we have v, and we have a constant. We are missing a term here, the v squared term. So when you set up your division problem, okay, let's go ahead and do that. Big old division bar, because you guys know I write huge. So we're dividing by 5v minus 3. Now, when I start writing this into my polynomial, right, or into the division box, I need to account for every power of v from 4 down to the constant. So we're going to have 45v to the 4th minus 27v cubed. Now, I don't have a v squared term, so I am going to add 0v squared as a placeholder, right? Because if this is times by 0, that becomes 0, and adding 0 doesn't do anything. So this is just a placeholder so that when we're stacking things up, it works into the problem. And then we've got minus 30v and then plus 16. Now, I'm going to start the division process as soon as I double check that I've got all the pieces in the right place. So 5v minus 3, 45v to the 4th, 27v cubed. There's my placeholder for v squared, minus 30v and plus 16. All right, so let's do a little bit of division. So we've got 45v to the 4th divided by 5v, which would be 9v to the 3rd. So multiply that together. And then let's see, minus 27v cubed. I'm going to subtract those. So let's see, first terms, 45 minus 45, those are going to cancel. And here's the thing, these are actually going to cancel as well. So negative 27v cubed minus negative 27v cubed, that's all going to cancel out. All right, so those are going to be gone as well, which is fine. Just go into the next part of the problem. Okay. Now, 5v, well, we could divide it into 0v squared, but it's not really going to help us. So we're going to ignore this term and go ahead and move on to the next term. So 5v divided into negative 30v would be, what would that be? Negative 6? Yes. All right, so let's stack it up. Negative 6 times 5v is going to be negative 30v. Negative 6 times negative 3 is going to be positive 18. And I'm going to subtract those. Remember, this 0v squared, in this particular problem, you don't need it. All right. In some problem, well, I shouldn't say you don't need it. You need it to set it up, but we're not actually using this term in this process because it's just a 0. All right. So those two are going to cancel. 16 minus 18 is going to be negative 2. So my remainder here would be negative 2 over 5v minus 3. So yeah, sometimes these problems aren't as long as some other ones, all right? It all depends on the polynomial. All right, so this is polynomial long division. Obviously, there's some other problems on the page. I will put those into the answer key so you can check your work. And if you have any questions or concerns, send me a message or ask the question in the